Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section, I'm giving the best tricks to find the number of bond pairs and number of lone pairs students, and also hybridization, how to find it. Okay, now I'm going to discuss, students. This topic is belongs to chemical bonding lessons, 11th class, first PUC topic, comma. Already in the previous video, I done how to find the hybridization, that is the first model, students. In this section also, I am going to discuss the second model, hybridization, how to find the hybridization. At the same time, number of bond pairs, number of lone pairs, how to find for the molecules, I will discuss, students. Okay, Nama. Now see, students, just I'm giving the two best tricks, Nana. You have to remember the tricks. You can easily answer this type of questions, students. Bond pairs, loan pairs, it is very important question for the competitive exam, students. So what are the best tricks? First one, example, students, best tricks. What are the best tricks? Now first trick, bond pairs. How to find the bond pairs, that is a trick number one, and how to find the lone pairs, that is a trick number two. Clear, students? Now trick number one, the number of atoms attached to the central atom is called bond pair, students. The number of atoms attached to the central atom is equal to bond pairs. Clear? This is a trick number one, students. Now I am discussing the trick number two. What is the trick number two, students? Trick number two means number of valence electrons of the central atom minus bond pairs. Okay, that is nothing but lone pair, students. That means number of valence electrons of the central atom minus bond pairs is equal to lone pairs. Understood, Amma? These two tricks you have to remember, students. And after that, bond pairs plus lone pairs. And trick number three, bond pairs plus lone pairs is equal to hybridization. Understanding, Nana? It is equal to hybridization, students. This is trick number three. Okay, now these three tricks you have to remember, students. Then you can easily answer any type of questions based on this topic. Clear? So how to find the bond pairs, how to find the lone pairs, and hybridization, this all I'm going to discuss now with example, students. So first, example one, students. One example I will take, BeCl2 beryllium chloride. Now I want to find first bond pairs. Okay, what is the bond pair? How to find it, students? Bond pair, the number of atoms attached to central atom. How many atoms attached to central atom? Two chlorines attached. This number indicates the bond pair. Okay, so how much is there here number? That only as it is you can take, students. Bond pair is equal to 2. Now how to find the lone pair, students? What is the lone pair formula? Number of valence electrons of the central atom. What is the central atom? Beryllium. What is the number, how many valence electrons present in beryllium atom? Beryllium atomic number 4, 1s2, 2s2. How many valence electrons are there? Only 2 valence electrons. Clear? 2 valence electrons. So 2 valence electrons minus what I told you, bond pairs. Bond pairs how many? 2 minus 2. Okay, 2 bond pairs. 2 minus 2 how much? 0. That means lone pairs are absent. Only bond pair is there. 2 bond pairs. Now I understood, Amma. How many bond pairs? 2 bond pairs. How many lone pairs, students? 0 lone pairs. No lone pairs. And what is the hybridization? Bond pair plus lone pairs is equal to hybridization, students. Now both you add, Nana. 2 plus 0, how much, students? What is the how to find it? Bond pairs plus lone pairs is equal to hybridization, correct? Hybridization. So that's why bond pairs, how many students? 2. Lone pairs 0. 2 plus 0, 3. 3 means which hybridization? sp2 hybridization. uh, s- Sorry, 2 plus 0, 2 no, no, sorry, 2 plus 0, how much students? 2. 2 means which hybridization? sp hybridization. Now see here, 2 means students sp hybridization, 3 means sp2, 1 s 2p, total 3. 4 means sp3, 1 plus 3 4. 5 means sp3d, 1 plus 3 4, 4 plus 1 5. So next 6 sp3d2, 7 means sp3d3. Clear? SP 1 S so 1 P, total 2. 1 plus 2 3, 1 plus 3 4, 1 plus 3 4, 4 plus 1 5. 1 S so 3 P, 4 plus D 2, total 5, total 6. 3 plus 1 4, 4 plus 2 6, 1 plus 3 4, 4 plus 3 7. Are you clear? Just you have to remember this table, students, then you can easily find the hybridization. So 2 means what, students? sp hybridization. Clear? So this is a trick number 1. This is example 1, students. Example 1 completed. Now I'm going to discuss the second example, students. Now see here, second example. Second example, sp2 hybridization, bcl3 I am taking. bcl3. Now tell me, students, how many bond pairs will be there? How many bond pairs? How many atoms attached? 3 atoms attached. 3 chlorines attached to the boron. That's a bond pairs is equal to 3. How many lone pairs? What I told you, number of valence electrons of the central atom. Boron is the central atom. How many valence electrons are there? Boron atomic number 5. 1s2, 2s2, 2p, 1. Correct? How many valence electrons there, students? 2 plus 1, 3 valence electrons. So valence electrons minus bond pairs 3, 3 minus 3 0 lone pairs. And after that you calculate hybridization. Bond pair plus lone pair is equal to hybridization, students. Which type of hybridization? This one. Now bond pairs 3, lone pair 0, 3 plus 0 3. 3 means which hybridization, students? We got bond pair plus lone pair is equal to 3. 3 means which hybridization? I told you 3 means sp2. Clear? 3 means sp2 hybridization. So write that one, sp2 hybridization. Okay, 3 means sp2 hybridization. Next example, students. Example 3. Example 3, students. SO2. SO2. So what about SO2, students? See here, how many bond pairs and lone pairs, how to find it? Bond pairs, how many, students? How many atoms attached to sulfur atom? 2 bond, 2 kada. So that's a bond pairs are 2 nana. 2 bond pairs are present here. Understood, amma? 2 bond pairs are there. Next, coming to the lone pairs, number of valence electrons of the sulfur minus bond pairs kada. So number of bond pairs, sulfur atomic number 16, no? 1s2, 2s2, 2p6, 3s2, 3p4. How many valence electrons? 6 valence electrons. 2 plus 4, how much, nana? 2 plus 4, 6 valence electrons. Clear? 2 plus 4, 6 valence electrons. Now 6 valence electrons minus bond pair kada. So when you are writing bond pair, students, here in the case of oxygen, this is exception, students. Oxygen, it is the exception case. Exception in case of oxygen. In case of oxygen, students, you have to take the double number. In case of oxygen, double you have to take. Double number you have to take in case of lone pairs. When you are calculating the lone pairs, you have to take the double the number. Now see here, students, lone pair 6 minus bond pairs, how many, students? Now here see, 2 bond pairs are there. These 2 bond pairs you have to multiply with 2. Okay, then you will get the lone pairs. So bond pairs 2 we got. Okay, then we have to take double number. Are you clear? So double number you have to take in case of oxygen. This is exception, students. Remaining all atoms as it is you have to follow, but in case of oxygen only you have to multiply with 2. 2 bond pairs. Suppose one bond pair is there, 2 into we have to multiply with 2. 3 there. there into 2, 4 there into 2, 5 there into 2, like this. Okay, so you have to multiply the bond pairs into 2 nana. So that means bond pairs how many? 2 already. 2 into 2, 4. 6 minus 4, then 2 electrons. 2 electrons is nothing but one lone pair. Clear? One pair. Pair means what? 2 electrons. That's why 2 electrons is nothing but one lone pair. Clear, students? One lone pair. Now see here, hybridization you have to find it. Bond pairs, how many? What? How to find the hybridization? Bond pairs plus lone pairs. Bond pairs, how many students? 2. Okay, plus lone pairs, how many students? 1 lone pair. 2 plus 1, 3. 2 plus 1, 3. 3 means which hybridization, students? sp2 hybridization. Clear? 3 means sp2 hybridization. Now see, students, another example is example 4. Now example 4. What I will take, sp3 sp2 completed. Now sp3 hybridization, students. Sp3 ammonia I'm taking, example nh3. How many bond pairs, students? How many bond pairs? Bond pairs 3. 3 atoms attached, 3 hydrogens. Lone pairs. How to find the lone pairs? Nitrogen valence electrons minus bond pairs. Nitrogen valence electrons, atomic number 7. 1s2, 2s2, 2p3. How many valence electrons? 5 valence electrons. So 5 minus bond pairs, formula 5 minus 3, you will get 2 electrons, means 1 lone pair. Clear? 1 lone pair. So how to find the hybridization? So bond pair plus lone pair is equal to hybridization. Correct? So now calculate hybridization. Bond pairs 3 are there. Lone pair 1 is there. Clear? 3 plus 1, 3 plus 1, students. Total 4. 4 means which hybridization? sp3 hybridization. Clear, students? 4 means 1 s, so 3p. 1 plus 3, 4. Are you clear, Tanna? Here already I told you one table. Clear? See here. 4 means which hybridization? sp3. Okay, sp3 hybridization. Understood, students? So 4 means sp3 hybridization. This is example 4. Now I am discussing the example 5, students. sp3d model. Example 5. What I should take? PCl5 I am taking. PCl5. Now tell me, students, PCl5, how many bond pairs? Bond pairs, how many, students? 5 are there. How many lone pairs, Nana? Bond pairs 5. Lone pairs, phosphorus valence electrons minus bond pairs. So phosphorus atomic number, how much, Nana? Phosphorus atomic number 15, 1s2, 2s2, 2p6, 3s2, 3p3. 15 kada. How many valence electrons? So 5 valence electrons. So that's why lone pairs means 5 valence electrons minus bond pairs. Then 5 minus bond pairs 5. 5 get cancelled. 0 lone pairs. Are you clear? 0 lone pairs. Now hybridization, how to find it? Hybridization is equal to bond pairs hybridization. What is the hybridization? Bond pairs plus lone pairs. Bond pairs, how many, students? 5. Lone pairs, how many, students? 0. 5 plus 0, 5 means sp3d hybridization. Are you clear? So sp3d hybridization we got. Understood, Amma? Clear? Now see, students, sixth example I am going to discuss. Example 6. sp3d completed, Nama. So sp3d2 now I am going to discuss. sp3d2 sf6 I am taking. sf6. Clear? So SF6, how many bond pairs, students? Bond pairs 6. How many attached? That number as it is, you have to take bond pair. Now coming to the lone pair, sulfur valence electrons, 6 valence electrons minus bond pair. So that means 6 minus 6, 0 lone pairs. Are you understanding? 6 valence electrons kada. Sulfur atomic number 16, 1s2, 2s2, 2p6, 3s2, 3p4. That means how many valence electrons, students? 2 plus 4, 6 valence valence electrons, correct? So 6 valence electrons minus bond pairs. Bond pairs 6, 6 minus 6, 0 lone pairs. Now here hybridization you have to find it. Hybridization is equal to what is the formula, students? Bond pairs plus lone pairs. Then bond pair 6 there, lone pairs 0. 6 plus 0, students, 6 means sp3d2 hybridization. Clear? SF6 hybridization. Now example 7. Example 7. Now tell me, students, example 7, I am taking sp3d3 hybridization, Nana. IF7 model, IF7. Okay, IF7 I am taking. So here, how many bond pairs, students? Bond pairs 7, 7 fluorines attached. How many lone pairs? Iodine is a 17th group element or 7th group element, halogen, 7 valence electrons, minus bond pair 7, 0 lone pairs. Now hybridization, coming to the hybridization, students, hybridization formula. Clear? Hybridization, what is the formula? Bond pairs plus lone pairs. So bond pairs 7, lone pairs 0. 7 means which hybridization? sp3d3 hybridization. Clear, students? sp3d3 hybridization. This is example 7. Now example 8. I am taking example 8, XeF2. XeF2. Now tell me, students, how many bond pairs? 2 fluorines attached, bond pairs 2. How many lone pairs, students? Xenon is H group element, 8th group element, it is a noble gas element, total 8 valence electrons, minus bond pairs. So 8 minus 2, that is equal to 6 electrons, means 3 lone pairs, correct? Are you understanding? 3 lone pairs are present. 3 electrons, 6 electrons means 3 lone. 2 electrons means 1 lone pair. Okay, 6 electrons means 3 lone pairs. Pairs means 2 electrons kada. 3 into 2, 6 electrons you will get. Are you clear? Now, hybridization, tell me, students, hybridization, how to find it? Bond pairs plus lone pairs. Bond pairs 2, lone pairs 3. Total 5. 5 means which hybridization, students? sp3d hybridization. Are you clear? XeF2 sp3d hybridization. Now take here one more example, students. One more example 9. XeF4. Now tell me, students, how many bond pairs? 4. Bond pairs 4 fluorines attached. Now coming to the lone pair, xenon valence electrons 8, 8th A group element. Are you clear? Suppose the element is first A group element, 1 valence electron, second A group 2 valence electrons, third A 3, fourth A 4 valence electrons, fifth A 5 valence electrons, sixth A 6 valence electrons, seventh A 7 valence electrons, eighth A group 8 valence electrons. Are you clear? So this is xenon, it is a noble gas element, 8 valence electrons minus bond pairs. So that means 8 minus 4, 4 electrons means 2 lone pairs. Clear? 2 lone pairs. Now how to find the hybridization, students? Hybridization, how to find it? Bond pairs plus lone pairs. Bond pairs 4, lone pairs 2, total 6. 6 means which hybridization? sp3d2 hybridization. Now I am going to discuss the last example, students. Example 10, XeF6. How many bond pairs, students? 6 fluorines attached. So that's a bond pair 6. How many lone pairs attached? Xenon 8 valence electrons minus bond pairs 8 minus 6, 2 electrons means 1 lone pair. Clear? 1 lone pair. Now what is the hybridization, students? How to find it? Hybridization, bond pairs plus lone pairs. Bond pairs how many? 6. Lone pairs how many? 1. No. Then how much you will get? 6 plus 1, 7 means sp3d3 hybridization. Clear, students? Understood, Amma? So like this you have to find the bond pairs, lone pairs and hybridization. Clear? I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Subscribe my channel. Thank you very much, students.